Good morning, class. So at this point we're looking at fractions. We are on skill 8. Is that correct? So yesterday we did skill 7, or in the previous lesson we did skill 7, adding fractions with unequal denominators. Today we're going to look at subtracting fractions with unequal denominators. So just to refresh your memory, if the denominators are unequal, what should we do? Find the LCM, the lowest common multiple. So if I go with that and find the lowest common multiple here, it's simply going to, this is skill 8, and skill 8 is on page 35. Okay. Okay, so let's look at number 1. So what we say is 5, is 5 divisible by 9, or is 9 divisible by 5? No. So what do? We're going to find multiples of 9. We always go with the biggest denominator. And the biggest denominator here of the two is 9, the largest. So we count in multiples of 9. So 9, is 5 divisible by 9? No. The next one? 18. No. Next one? 36. No. Then? 46. 36. Okay. So it's 9, 18. 27? No. 36? No. 45? Yes. So 45 is your LCM here. Your lowest common multiple. Some people call it the LCD, the lowest common denominator. The same thing. So 9 multiplied by what is 45? 5 times by 5. 5 times 5? 25 minus. 5 multiplied by what is 45? 9. So 9 times 2 is 18. So 25 minus 18 is 7. Is that correct? It's 7 over 45. Any confusion here? No. Let's go with the next one. In number 2, is 9 divisible by 7? No. So we count in multiples of the largest denominator. So it's 9. 18. No. 27. No. 36. 45. 54. 63? Yes. So 63 is the lowest common multiple where both 7 and 9 are divisible by. Okay. So that will give us 63 minus 63. That minus comes from that negative thing. Okay. I can write it apart, or I can write it as I did here as well. Whichever one you prefer. Okay. I normally do it as I did in number 1. So 63, 9 times what is 63? 7. So 7 times 8 is 56. 7 times what is 63? 9. So 9 times 3 is 26. So what is 56 minus 27? They say 56 minus 27. Remember, there's no calculators to be used. There's going to give you 4. As 6 is too small to subtract 7. There's going to be 4, 2, 1. 16 minus 7 is 9. So I get 29 over 63. You all okay with that? Any confusion there? Let's pull this up here. Let's start this up. Now we're looking at number 3 and 4. Okay. Look at number 3. Is 7 divisible by 3? No. So we're going to count in multiples of 7. So we go 7. Is 3 divisible by 7? No. 14? 21? Yes. So 21 is your LCM. Your LCD or LCD. So 3 multiplied by what is 21? 7. So 2 times 7 is 14 minus. 7 times what is 21? 3. 3 times 3 is? What is 14 minus 9? 1. So it's 5 over. Any confusion there? Let's go with the next one. Number 4. Is 7 divisible by 5? Or can 5 go into 7 without remainder? No. So we count in multiples of 7. So 7, 14, 21, 24, no, 21, 28, 35. Yes, so 35 is your LCM. Okay, 7 times what is 35? 5. 6 times 5 is 30 minus 5 times what is 35? 7. 7 times 2 is? The 30 minus 14. 16 over. So anything that's an issue there, you all understand. Am I moving too fast? Okay. So now we're looking at working with mixed numbers. Okay. This is of course skill 9. Okay. So in number 1 we have 1 plus 1 and 5 over 7, 1 and 5 sevenths plus 2/3, or 2 over 3. So what I do is I always convert all my mixed numbers to improper fraction. If you feel that if you want to add and subtract using the whole number as it is there, and keeping the whole number on the side of the fraction, in front of the fraction, there's no problem. However, when you multiply and dividing, you must convert anyway to improper fractions. Not so? So you will always see me, and that's the method I use, to always change mixed fractions to improper fractions. Okay? And because I always leave the answer in improper form anyway, that is why improper is the word. Okay? But like I say, you decide, or if you feel that me working with the whole number in front of the fraction, there's no problem with it. I know how to mark it as well. Okay? You'll see on the memos as well, both the answers are both methods. Okay? So let's go. I always convert to improper fractions if necessary. So that will give me 7 plus 5 is 12 over 7 plus 2 over 3. Alright, so what is your LCM here? 21. You all know how we got 21? Who doesn't know? Right. 21 is my LCM. So 7 times what is 21? 3. 3 times what is 21? 7. So 3 times 12 is 36 plus 14. 36 plus 14 is what? 50. There's 50 over. Again, if you want to convert it, it would be 2 and 8 over 21. Yes, my girl? You're going to ask. Yeah, it's going to be 2 and 8 over 21. Okay. You all okay with that? Let's look at the next one. So what do we do first? What do I do first? I convert to improper fraction. So that is going to give you 12 over 5 plus, that is 12 is 13 over. So what's my LCM here? 20. How do I get 20? I count in 5. So it's 5, 10, 15, 20. Yes, 4 goes into 20. So LCM of 20. So the sum is multiplied by 4. So this here? Why by 5? Why are we multiplying the numerator also by 4? Who can tell us? We spoke about this yesterday, yes? Due to the numerator, but why? Why are we doing what we do to the denominator to the numerator? Yes, Michael? We want to find equivalent fractions. That is why. Okay, the fractions needs to be equivalent. Okay. So 12 times 4 is 48 plus, you must times that by 5. 15 times, 13 times 5 is 63. Is that correct? 65. Sorry, 65. Absolutely correct. My mistake, 60. Now what? It's going to give you 113. Is that correct? So it's going to be 113 over 20. Or can be written as 5 and 13 over 20. You all agree with that? See any confusion? Would you like me to pause the video at this point? You all understand. I don't need to redo this. Who wants me to redo it? So you all understand, eh? Mustn't be shy, eh? You must tell me. Because later on when students watch the video, they had a problem. Maybe with you asking the question will clarify the question that they have in their heads, okay, in their minds. Right, so let's look at number 3. So what do we do first? Change to improper fraction. Okay. So times by 4 is 20 plus 1 is 21 over 4 minus 2/3. What's your LCD here? 12. How do we get 12? We count in 4s. Okay, 3 going to 4? No. 8. 3 can't go into 8? No. 12? Yes, 3 going to 4 and 12. 4 and 3 goes into 12. Okay. So 4 multiplied by what is 12? 3. 3 multiplied by what is 12? So 21 times 3? 63. 62. 63. 2 times 4 is? What is 63 plus 8? 63 minus 8. 50? 5 over? Okay, you all agree with that? 48 is going to give you 4 and 7 over 12. Alright, you guys understand?
Yes, sir.
Any problems there? Any confusion? Okay, let's look at number 4 quickly. So what do I do first? Convert to improper fraction. 3 times 5 is 15 plus 1 is 16 over 5 minus 16 over 5 minus there's 3 for 5 over what's my LCM? 15. 3 can't go into 5. 10? No. 15 is. So 15 is your LCM. So I must multiply 5 by 3. 3 by? So 16 times 3 is 18 carry 1 is 48. Correct? Minus 25. So again we say 48 minus 25 is 23. You all agree with that? Or it can be written as 1, and if you take 15 away, you're going to get 18. Is that correct? No, not 18. 18. It's 8 over 15. Is that correct? 13 is 80s. Okay. You got any confusion here? No. Now we're going to look at when still skill 9, correct? Now we're looking at multiplication and division. And this is also the reason why I convert everything to improper fractions, because then I do it uniformly. I do it for all of it. I always do it in that manner. Because when we're busy with multiplication and division of fractions, you must convert it to improper fraction. There's no two ways about it. You guys understand? Right. So let's do this quickly. So, looking at number 5, what needs to be done first? We convert. So 7 can be written as 7 over 1. 9 times 3 is 27 plus 1 is 28 over. You all agree with that? Is there any numerator and denominator that can simplify it? 3 and 7? No. 3 and 28? No, of course not. That's coming from there. And 1 and 28? No. So in other words, we must just say 28 times 7. 7 times 8 is 56. 5, 14. I'm going to give you a 19. Is that correct? Right, so it's 196 over 3. If you want to write this as an improper fraction, as a mixed number, it will be 6. And it goes 18, so it's 6, carry 1. 15 is 5, and 1 over 3. Okay, but I would accept 196 over 3. Okay? If you look at number 6, what needs to be done first here? Change it to improper fraction. So what would this fraction here be? 5 1/4. 21 over 4 multiplied by 3 2/3. It's going to be 9, 11 over 3. So what do I do now? I first simplify before multiply. You see, if I multiply this 21 times 11, it's going to be a huge number. Can you see that? And over 12. So if you're going to keep it small, if you're going to simplify first, you'll see the numbers won't be that big. Okay? So 3 goes into 3 once, 3 goes into 21. Is there anything else that can simplify it? So 11 times 7, 77 over 4. If you want, again, you can convert it into mixed numbers. Any questions here? Any confusion? Who understands? Put up your hand. Okay, it's just you. Yes? Factors. If that was an 8, then I would have said 4 going to 4 once, 4 going to 8 twice. It's absolutely. Okay. Anything else, people? Alright. So what I'm going to do is I'm going to take this off. Alright, so let's look at number 7. So what do we do first here? Change to improper fractions. Multiply and add. So 2 times 2 is? Plus 1 is? So it's 5 over 2 divided by 2 over 3. Now what do I do? Swap it around. Change the multiplication. I could have done this in this step already. In the first step as well. Okay? If you are comfortable in doing it in one go, no problem. However, number 8 you can't. Why? Because I must convert that first. You see that fraction here? Must convert first. So we swap around. So it's 5 over 2. Remember, we only swap around what follows the division sign. So it's 3 over 2. Right. Now we ask ourselves, are there any numerators and denominators can cancel? It can only cancel across a multiplication. If you couldn't say 2 goes into 1, 2 goes into 1. You can't do it like that. It has to be across a multiplication sign, from one fraction to the next. Unless it's in the same fraction, the numerator and denominator cancel. So what do we have here? 5 times 3 is 15 over, or 3 and 3/4. Okay? Yes, Michael.
So why do you swap the 2 and 3?
You see, because why we don't divide manually. That is why. Okay. Then let's make it in this formula. What is 1 divided by 2? Huh? What's 1 divided by 2? 1 over 2. Not so. It's wrong. So let's go and say, okay, if I now want to make it both fractions. So this would be 1 over 1 divided by 2 over. Not so. So it changes to multiplication with tumbling times. So it becomes 1 over 1 times, 1 over 1 times, so multiplied by 1 over 2. Anything that can cancel it? No. So 1 times 1 is 1. 1 times 2 is 2. You understand? So that is the reason. So when the reason for that is because I can't divide manually. Okay. Otherwise, all that steps of swapping it around and all that must be done in my head. Okay. And I don't have such a big head yet. So, I don't know. Right, yes? Sorry? What? Music. Did I speak to you about this already? Okay, so let's look at number 8 quickly. So what happens here? We must first convert to improper fractions. So it's going to be 35 plus 5 is 40. So it's 40 over 7 divided by 2 times 1 is 2 plus 1 is 3 over. So what do I do now? Change to tumble and times. Not so. So it's going to give you 40 over 7 times 2 over 3. So is anything I think then can simplify and numerator denominator? No. 40 times 2 is 80 over. Okay. Any confusion here? Yes, Michael? Yeah, diagonal, which is numerator and denominator. So only numbers that can simplify here is 40 and 3 or 7 and 2. If I had another fraction here which was maybe 7 over 8, then I could have simplified 7 going to 7 once, 7 going to 7 once, 2 going to 2 once, 2 going to 4, 8 to 4 times. You understand? So even across the third fraction as well, as long as it's multiplication between. Anything else? No. Also, you could have simplified that and that if it could. No? But because it's coming from that setting, it won't. Okay. Any other questions, people? So for homework, I would like you to do skill 8 and 9 from the fraction practice, the odd numbers. Okay. You can start now, and I will check your books row by row.